In this video, I'm going to give an introduction on student loans, and then I'm going to do an example where we calculate student loan interest that accrues while a student is school, the regular payment on a student loan, and then the total cost of a loan. So let's start by just going over the different types of student loans. And really, there's two main types. You can get a federal loan or a private loan. And then, of course, there's a combination, just means you're using some of each. And so a federal loan, that means the loan is from the government. And there's a couple of advantages to getting a federal loan. So the main advantage is that there are lower rates. So that means cheaper for students. So students save money here because the rates are lower, which is nice. Oftentimes, there might even be some wiggle room in terms of repayment on these loans. There's loan forgiveness programs that the government offers depending on what career you're in. And so that can sometimes help people depending on, whether or not you're eligible, of course. Whereas with private, there's much less flexibility with that. The downside of federal loan, there is a cap. And there are caps usually on private loans too, but the cap is much lower on a federal loan. So sometimes students might be able to get a federal loan, but it might not be enough for them to pay for their entire school. And so private loan, definitely a higher cap, higher interest rates. They do check your credit with a private loan, so you can be denied if you have poor credit, whereas with the federal loan, they do not check your credit. So there's definitely pros and cons of both, but federal loans tend to be more ideal for most students. And so in terms of a federal loan, they will offer you either a subsidized or unsubsidized loan. The subsidized loan, this is definitely the best option for sure, because the government pays the interest while the student is in school. So not the entire interest over the life of the loan, but at least while the student is in school, the government's paying for it. Whereas an unsubsidized loan, and this could be either through the government or with a private loan, all private loans are unsubsidized, the interest accrues, which means adds up. So accrue just means adds up while the student is in school. And that amount is added to the principal when the payment is calculated. And so it's definitely more money in the long run for students. So a couple other things with interest that I want to talk about. So interest can either be capitalized or uncapitalized. Capitalized interest is when students are not paying anything while they're in school. And so the interest accrues, which again means adds up, but they're not paying anything. And that has obvious benefits to the student at first because, they don't have to pay anything. But the downside is that it definitely is more money in the long run because that interest that accumulates while they're in school ends up getting added to the principal, and students end up paying interest on that interest in the long run. Whereas if the interest is uncapitalized, then the students make interest-only payments. It's paid monthly while they're in school, and then they don't have to add that to the principal when the payment is calculated. And then I do want to mention one more thing. It says in parentheses here, and deferment period. So what does that mean? If interest is deferred, that just means that it's put on hold for a certain period of time. Oftentimes it'll be 6 months after a student graduates, where they don't have to make payments. So it's put on hold, student doesn't make payments. And that can seem good to students because they don't have to make payments, but that is a period where that interest is still accumulating. It's just they're not paying on it. So even though the student is not paying, that's not necessarily a good thing over the length of the loan, because it does mean that they're going to have to pay for that at some point, and probably more because they're going to pay interest on that. But anyway, so we're going to do a problem where we kind of put all of this together. And below I have the two, well, it's really three formulas that we're going to use to calculate monthly interest. So you can see right here the monthly interest amount. Really, it's a very simple equation. You're just taking the daily interest amount times the number of days in a month. We've got a daily interest formula here, which I'll show you how to use in a second. And then we've got this monthly payment formula here. That one's a big one, and I'll show you a couple of options of how you can do that one in your calculator. So let's jump into an example. So for the given loan, which is this loan right here, this $8,700 loan. So we're going to call that P at a 7.7% interest rate. We're going to find the interest that accrues in a 30-day month. So that's our first problem that we're going to try to do. And then we're going to find the total interest that accrues before payments begin. And so that's the second problem that we're asked to do. And so before we jump into the actual problems, I just want to convert this percentage right here. So we have a 7.7% interest rate. I want to convert that to a decimal because in all of the formulas, the rate, the lowercase r variable, should be in the form of a decimal. So we're going to take this decimal place, our decimal point, and we're going to move it 2 spots to the left, and we're going to put a 0 in the placeholder, and that gives us 0.077. So we've got our p-value, 8,700, and then a 0.077 rate. And so if we want to find the interest that accrues in 1 month, what we're going to do first, so our step 1 is we're going to find the daily interest. And we're going to do that by using the formula that I showed you on the previous page. And so what we're going to do is we're going to take the principal, which is 8,700, and we're going to multiply that by the rate, so P times R, and we're going to divide it by 365.25, number of days in a year. And then we're going to get 1.83408. It's a long number. Now in this step, you always want to round to the nearest cent, which is the hundredth place. And so we're going to look 1 to the right of the 3, and since that's a 4, it's less than 5. So rounding rule says that we leave the 3 alone. So we're going to round to $1.83 per day. That's the amount of interest that accumulates, adds up while the student is in school for each day. Step 2 is we're going to find the monthly interest. And we're going to do that by just taking the daily interest, so $1.83, and we're going to multiply it by the number of days, and we're going to use 30. It says it in the problem, but I would say it's a good rule of thumb. If it doesn't tell you, then just use 30. And so we multiply those two numbers together, and we get $54.90. And so that's the monthly interest rate. That's the amount of money that accumulates each month while the student is in school. So that was the first question that we were asked, so we did that. So the second one, we want to find the total amount of interest. So we know they're racking up $54.90 every single month in school, but let's figure out how long they were in school for so we can get a grand total. So step 3, we're going to figure out how long were they in school, how many months, and that is called the accrual period. And so you need to go back to the problem and figure out, well, how long were they in school? So the second line says, the student graduates 3 years and 6 months. So I'm just going to write down 3 years, 6 months. And then you got to look for a deferment period if there is one. And it says on the third line, payments deferred for 6 months after graduation. So that's another 6 months that they're not making payments on the loan. So we've got to account for that also. So we want to make sure we get this all in months because right now we have a years in there also. So I'm going to take 3 years and I'm going to multiply it by 12 because that'll give me the number of months. So 3 years is the same thing as 36 months. And then I'm going to add the 6. And I'm going to add that other 6, and I'm going to get 48 months total. That's the amount of time that the student was in school. So step 4 is we're going to find the total accrued interest while they were in school. So we're going to take the number of months, 48, how long they were in school, the accrual period, times the monthly interest rate, and we're going to get $2,635.20, and that is the total amount of interest that accrues while they're in school. And so this would be capitalized interest since we're adding this up. Now, if the student decided to go the uncapitalized route, then they would be making payments on this while they were in school, and this number wouldn't be needed to be added to their principal when payments are calculated. So let's jump to the next problem, which is just related. It's related to this one. It's an extension. We're going to find the regular payment on this loan. And so what we're going to do is we're going to take our original principal of $8,700 and we're going to add that $2,635.20. So that was the interest that accrued while the student was in school because that needs to be added. They also have to pay that back. And then that gives us $11,335.20. And so that's going to be our new principal that we're going to use in this formula. So I'm going to go ahead and write down the formula. So we've got R, big R stands for regular payment, equals the principal times the rate over 12, and it's always rate as a decimal, divided by 1 minus 1 plus rate over 12 to the negative 12 times t power. Now sometimes you'll see this formula, you'll see a negative 120 here instead of negative 12 times t. A lot of times the t will be 10 years, and so 10 times negative 12 gives you negative 120. So if you see that and you're wondering, that's a little bit different, that's why. It's just because t happened to be 10. I'm going to leave it like this though. I think it's flexible this way. That way, if you run into a problem where the term isn't 10 years, you'll know what to do. So I'm going to go ahead and I'm going to plug all the numbers in. So for P, 11,335.20 times my rate over 12 divided by 1 minus 1 plus my rate over 12 times negative 12 times 10. Now, and at this point, it would be a really good idea for you to just pause the video and try to evaluate this on your own with your calculator, and then you could check with me. I'm going to go over a couple of options. So if you have a TI-34, a TI-30, or a newer TI-84, those calculators have this N over D button. And the nice thing about that is it makes a fraction, and so you can actually enter in the problem just like it looks on your paper. And so even at this point, when I've got the that fraction on the top, I can put a parenthesis and press the N over D button again and just plug in 0.077 divided by 12. You got to make sure, be careful with the arrows. Sometimes you'll get stuck in the denominator and it's easy to kind of mess things up. But if you go slowly and just pay attention after you do each step and make sure that it looks like what you have on paper, it's a really good option. So 1 plus, I'm going to put the N over D button again. So 0.077, arrow down, 12, and then I'm going to arrow to the right to get out of that fraction, parentheses, and then I'm going to put the exponent key as this little arrow. Sometimes it's called the caret key. And then just be careful when you've got a negative 12, you want to put the negative key in, not the subtraction. So there's a difference between the negative key and subtraction. So negative 12 times 10, and we end up getting this number. And I'm going to actually put it way at the bottom here because I'm going to show you this long way too. So 135.7369905, and we will round that at the end. So that's one option. If you don't have this kind of calculator where you have that button, then this is what you're going to do. You're going to do the numerator first. So I'm going to just plug in 11,335.20, and I'm going to do this without the fraction button. So I'm just going to put parentheses 0.077. Whoops, too many zeros. So I'm going to go back. 7. Oh. Okay. There we go. 0.077. And then I'm going to delete this extra 7. And then for the 12, I'm going to just press the division sign, because 0.077 over 12 is the same thing as divided by 12. So you just use the division sign. In some calculators, it'll look like a slash, and that's okay, like a forward slash. And then I'm going to hit enter. And so for the numerator, I'm just going to write down that answer. 72.7342, and then I'm going to go ahead and I'm going to do the bottom. Now the bottom is a lot bigger, so rather than put this all in at once, because that sometimes can lead to mistakes, I'm just going to do the inside. Now if you start with the 1, you will have to put parentheses around this part, just like we did up top. If you don't want to bother with that, if you want to make it quicker, then just do the 0.077 divided by 12 equals, and then add 1, okay, and then we get this number. And so I'm just going to write 1 minus 1.006416667, and then it's raised to the negative 120 power. I'm running out of room there. So negative 12 times 10 is 120. And so the next thing I'm going to do is I'm going to raise that number to the negative 120 power and take advantage of the fact it's in your calculator already. So just leave it there and press the exponent key, and that way you don't have to type it in again. And then the negative key, 120 equals. Okay, so then I'm going to come down here, I'm going to write down my numerator again. And then I've got 1 minus 0.464153,436. Keep in mind that if you have a different calculator, like before the video, I was doing this using my phone calculator, and my screen is actually bigger. So when I did this denominator, I actually got more digits, so it looks a little bit different. So if you're using like a phone calculator and you get a few more digits than what you see me writing down, that's why. And so no worries on that. And so then the next step, I'm going to subtract that from 1, and I'll show you a trick you can do with most calculators. Whoops, gotta get my calculator back here. What you can do is you can just, whoops, and I just deleted that. The trick that I was going to show you is you could do 1 minus and then use the answer key. But you know what? We're just going to type it in. So we're just going to do 1 minus 0.4641 5, 3, 4, 3, 6. Let's see. I think I have too many 3s there. 1, 5, 3, 4. Should be 1, 3. There we go. Okay, and so in the denominator, we'll have 0.535846564, and then the numerator. And now I can show you my trick with the answer key here. So what we can do here is we can type in 72, the numerator, 0.7342. And then I'm going to divide it by, instead of typing this all in again, I can press second answer. So ANS, you can see right above that negative sign, that just means the previous answer. It just uses the previous answer and plugs it in for you. If this is, not something you want to even try, then just, type it all out and you'll be good that way too. And so when we do it this way, we get $135, 0.7369906. Now you'll see we're a little bit off here, and that just has to do with slight rounding differences with the different methods. It is so slight it would never make a difference in terms of your final answer. So in terms of rounding, we're going to round to the nearest cent, which is the hundredths place. This 6 tells us to move that 3 up to a 4. So $135.74 per month. That's what the monthly payment is going to be on this loan. And this is for 10 years. The student is making this. Okay. And so really what we're going to do next is we're going to figure out, well, what is the actual total? So we know the monthly payment, but anytime you take out a loan, it's good to know how much you pay total after the loan is completely finished. So let's just scroll down here and let's do that. And before we do the overall cost, let's talk about what type of loan we just did also. So we calculated interest that accrued. So we calculated accrued interest. So that means that interest was calculated. Okay, or I'm sorry, capitalized, because the student did not make payments. We needed to calculate that accrued interest. And the government did not pay that interest while the student was in school. There was nothing in the problem saying that it was a subsidized loan, so that we can assume that it was an unsubsidized loan with capitalized interest. And so lastly, we're going to calculate the overall cost. Think A usually means future value. So if you've ever seen future value in other interest equations, that's really what we're thinking here. And so overall cost, we're just going to add up all of the payments that the student made throughout the life of the loan. So the student pays $135.74, and they pay it 12 months a year for 10 years. And so we're going to multiply So this is just going to be our term, and we're always going to do times 12 because it's the payment per month. And so if we multiply that out, we get $16,288.80, and that's the total cost of the loan. Now keep in mind that because the interest is capitalized and the student is not paying interest while they're in school, this is how you calculate the total overall cost. If the student was making payments while they were in school, then we'd have to take their monthly payment and do this, and then also add in those payments that they made while they were in school. Believe it or not, it actually ends up being a lower overall cost when they make payments in school. But just, a heads up in case you run into a problem like that.